Hello everyone, today we'll come to know about Turing machines. Turing machines were created by Alan Turing, the same person who cracked the ENIGMA code. Turing machine is a sequential model of mathematical computation, which means it solves problems one by one. Now let's understand it the easier way. Now let's take a cardboard square which can contain the number 0 or the number 1, or the cardboard square can be empty. Now let's combine them to form a strip of them. So it will look something like this. Now in this, each cardboard square represents a state, whether empty or 0 or with a 1. So now our machine should be able to read one state at a time. Now it is slowly reading through it. Now there should be a program that should instruct it. Like if the machine is at state number 2 or state number 5 and it has the number 0 in it, then make it 1. If there is a blank space in the 7th state, then move 2 state forwards. It can give these types of instructions. And by doing this at the end, we will have a set of zeros and ones combined together. And this will be the solution to our problem. So you can say these are the basics, but let's dig a little deeper. Turing machine defines an abstract machine which manipulates symbols. An abstract machine is a machine that doesn't exist in the real world. It has an input, an output, and a set of allowed operations inside of it. Turing machine is one of the first models of computation or sequential computation, and there is no such problem that a Turing machine cannot solve. The computers we see and the electronic devices are Turing machines. The paper of this Turing machine is on computable number with an application to Entscheidungsproblem. Now, in fact, one of the things that is really going on is that is there any problem that a quantum computer can solve but not a Turing machine? Now, we have found till now that Turing machines are slower than quantum computers, but they can solve every possible problem. So they are as good as them. And this is a big achievement by Turing machine. And in fact by Alan Turing. Turing machines proved the existence of fundamental limitations on the power of mechanical computations, a very big achievement. Turing completeness is the ability for a system of instructions to simulate Turing machines. A programming language that is Turing complete is theoretically capable of expressing all tasks accomplishable by a computer. Nearly all programming languages are Turing complete if limitations of finite memory are ignored. Turing machine minimalist design makes them unsuitable for computation in practice. A real-world computer are based on different designs that are unlike Turing machines and use the random access memory implementation. Random access memory is a different model of computation that exists out there. Now we move on forward. A Turing machine can be formally defined as M is equal to QB sigma delta Q, 0 and F. Q is a finite non-empty set of states in a Turing machine. T is the finite non-empty set of tape with alphabets. And Alan Turing was a great person who was persecuted for his gender. He committed suicide in 1954 because of the torture being done to him. But his Turing machines make him alive forever. So a very important announcement now. If you want free materials and textures, then go to quartz.unox.com. It's a website made by me where you get free materials and free textures. So if you like the video, hit the like button and press the bell icon out there to receive more from BRAINSOR.